This leads us into calculation programs, and you may get a set of instructions similar to here, where you say choose a positive integer, that's a whole number, raise this number squared, so you square it, add 3 to the result, and you do various other things, and we write the final result. There could be a whole host of different types of questions for this. I'm going to show you with one number and then with algebra. So let's pick a number, let's pick 3. Raise this number squared, so I've got 3 squared. And what does 3 squared equal? That equals 9. Okay, add 3 to the result, so I've got 9 plus 3 equals 12. Then multiply by 2. So I've got 12 multiplied by 2 equals 24. Subtract 6 from the previous result. So 24 minus 6 equals 18. Take half of the result. So I do 18 divided by 2 equals 9. Now notice what I've done here. I haven't written equals. I've literally done what's this instruction lines up with here, and then each calculation lines up with the instruction that I have. Calculation and answer. Nice and clear. Now let's do it with algebra. Let's say we chose the number x to go in. Choose a number x. Square this. Raise this to the numbers. Raise this number squared. So x squared. Add 3. So that will be x squared add 3. Multiply the result by 2. So it's 2 multiplied by x squared plus 3. Note how I put my 2 in front, because it's multiplying a bracket, it just looks neater. Subtract 6 from this previous result. 2 x squared plus 3. Subtract 6. Take away half the result. So that's just going to be 2 x squared plus 3 minus 6 divided by 2. Now that last thing here, I'm going to put a little bubble around it, is pretty complicated. So let's try and tidy that up. So let's take it over here and see what we get. I'm going to expand the bracket at the top. 2 times x squared is x squared, plus 2 times 3 is 6. And I'm taking away 6, and I'm dividing by 2. Well, I can see the plus 6 minus 6 would cancel, so that's the same as 2x squared over 2. And now I can divide both the top and the bottom by 2, and that's going to give me x squared. What does this prove? Well, what this shows is that for any value of x that goes in, I get the square of that number coming out. And if you look at it, I put 3 in on my example here, and I got the square of 3 coming out, 9. So this, using a number, just shows me the answer for one number. Using the algebra shows me the answer for all numbers. You may get to be asked to form an expression such as this one, using a figure, and they simply want the perimeter of this shape, and you need to just identify the measurements. So all of these lines that have the little dash on mean they're the same length, so each of these is the length of x, and anything with a circle will also be the same as each other, and all of them are 2.5. So I can look at that and go, how many x's do I have? Let's have a look, I have 1, 2, 3, 4, 5, 6. So I have perimeter equals 6 lots of x, which is 6x. And then how many of the dot ones I have? I have 1, 2, 3, 4. So plus 4 multiplied by 2.5. 2.5 is 10. So my perimeter of my shape is 6x plus 10. Show your workings on this just to make sure you show the examiner exactly how you're getting your final answer. So show this stage here. Very, very important. You may have an expression like this, where you want the volume from a cuboid. Remember, the volume of a cuboid is length times width times height. So my volume 1 is equal to the length, which is 2x plus 4, and put it inside a bracket, multiplied by 2x multiplied by x. So it is this times this times this. Let's tidy this up a little bit. I'm going to leave the bracket alone to start with, and I know 2x times x is 2x squared. Now I told you before, when you have something multiplying a bracket, bring it in front. So 2x squared is going to go in the front, 2x plus 4 is on the outside, and then I expand. 2x squared times 2x, 2 times 2 is 4, x squared times x is x cubed, and then I do 2x squared times 4, so 2 times 4 is 8, and that's a positive 8, and then I have my x squared. So my volume is written like that. If I wanted to factorize that, just to make it even more simpler, I suppose, I would say, what's the common factors here? I have 4 on the outside and x squared. X squared is also a common factor, leaving me with x plus 2. That is also an expression for the volume. Take a moment to reflect on that to see if you can see the progression there and how to get the two answers and how they are both the same. In this problem, you are asked to express the area of the L shape within the rectangle as a function of x. So you're forming an expression from this image and this information here. The L shape is this shape here, so let me just shade that in red so you can see. This is the one we're trying to find the area of. And there's enough information on the image to actually do this. Now if you look, you have a length of 5 and length of 5. The units are not shown, they're not important for this particular problem. And you have a measurement of x here, which has a little double dash on it, which means it's the same as this length here. So let's write x onto that piece as well, like this. And let's also write the whole length of the entire rectangle here, which is going to be x plus 5. And I'm going to put that inside of parentheses there. It's x plus 5. Put it in parentheses because you need to treat this as one thing. Now to work out the area of the red here, the L shape, you need to work out the area of the large rectangle, the small rectangle, and then find the difference between the two. So writing this down in the exam, you really want to set it out clearly. So I'm going to put the area of large, and then I'm going to do area of small. That's enough to explain to the examiner what you're doing. And then the area of the L. So there's a logical process of what I'm doing. The area of the large one, it's a rectangle, so it's length multiplied by width. So I'm going to write that as 5 x plus 5. I could do them the other way around, but I like it when I'm multiplying a number by a bracket to put the number term, the single term, outside at the front rather than at the rear. The area of the small one, well, that's easy. It's just length times width, 5 times x, so that can be written straight away as 5x. And then the area of the L shape is the large one, so it's 5x plus 5 minus the small one, 5x. Now that would not get you full marks because yes, that's an expression for the area, but clearly we can expand and simplify all of this. So let's try that. So that is equal to, let's expand the bracket, 5 times x is 5x. And then 5 times 5 is 25, and that's a plus 25 because it's a plus 5. And then I have minus 5x at the rear there. Now you should be able to see that 5x subtract 5x equals 0, so we would say they cancel each other out. So that just leaves me with the answer of 25, much simpler than this expression here, and that is the expression for the area of the L shape.